it for every single one of these things at the same time, and we end up with all these points. When do we stop the simulation and actually render out what we've got? Because basically what we want is the position, the direction, and all this other stuff put together. And how do we figure out the speeds? So like, you know, because like obviously the water is going to be flowing very quickly through here, but it's not going to be flowing that quickly other places. We are going to see a little bit of eddying forming. So, you know, that's okay. Do we run it for a certain number of iterations, like run for 1,000 iterations and then render out what exists at that point in time? Or do we have like some good end condition? And how do we update this? I think we just like keep a number of particles in an array. Like we could have it so it actually like goes through to a maximum number of particles on the thing. I don't think we need to worry about being super crazy efficient on this. We're not trying to do it in real time dynamically. I guess we would want the direction that we moved last, or kind of our historical direction. So this point would have the direction that it moved previously, which would be like, you know, from the right, so it would be this direction vector. And I guess the speed value for the flow field would be a percentage based on the movement that, because we have this. When would we speed up and when would we slow down? I guess we would speed up when we could move in the direction of the thing, and we would slow down otherwise. So we would take our current speed value, which would be between, you know, we could start with a maximum speed of like 10 pixels or something, and then we could go to a minimum speed of 1 pixel move. So what we would get would be a direction vector, which would be the history of our object, and then the speed value would be our actual speed value that we were able to move at. Alright, so I think we render out the flow field after X iterations of simulation, and we want to, the values rendered are the historical direction of the particle for X ticks, and the speed of the particle, which is a minimum of 1 pix. And we would want a maximum speed, needs to be input. Should we have the shore just create the flow field itself? Is there something where we can take our shore blurred texture and just turn that into a flow field? Like we could add that in directly to this thing with like an opposite direction? You know, as in a repulse value, each one of those, we could take our blurred out height map sort of thing, and each pixel could check and create a direction vector. Basically, it would check all 8 directions or all 16 directions around it and get like So we could create like a shore flow field pass as well, and we could average that in there. All right. So it'll be calculate a shore flow field repulsion texture. Add that in there with a weight. So we could keep things away from shore basically if we needed to. So, but we could also kind of figure that out. We can actually just add in, move away from shore first, and these things should not need that theoretically. But then kind of areas like this wouldn't get flow through. All right, well, I think we got enough information as to how we want to actually write this. So, what are some steps here? We need to compute paths, A star paths between inflow / outflow. We need to create the simulator with particles and run it, all that. Alright, well, I'm going to be right back, and I think we'll actually start coding some of this. Alright, back to texture land, right? So what we're going to want to do is add to this guy, we're going to want construct static flow field. We're going to be able to call that, and we're going to want to actually call C++ stuff nicely in order to do that. And what are we going to get out of it? We're going to get a texture asset, and we're going to set it. So let's see, we call fill height array, which is in the physics util. So we're going to need to make a new thing. Let's call this something different. This will be like map utils. So we're gonna add a new C++ file here. We'll do utils map. So Dashkin map utils. And we're kind of letting the blueprints use these functions and all the rest a la carte, which is not what, I mean, it's not very object oriented. It's more how you would program something in, I guess, C or whatever. But I'm kind of just breaking everything apart into simple operations that I can do. So we're going to have this thing return an array of colors, is it? Inside of physics utils. So let me through all this. It's, yeah, fill height array, and it's a T array of F colors for the output. Alright, so what are we going to want to pass in here? We're going to have this will be create static flow field. We're going to want a T array of colors, which would be input. We're going to want a T array of colors for output. We're going to want int32 width, int32 height. I guess we're going to want the actual component for this thing. So we'll have our actual component. Are we going to want like an array of sources to input for this thing and locations of those things? Like, how are we actually defining inputs and outputs for this flow field? You know, this is where a waterfall is, this is where something else is. I think what will probably happen is we'll scan the level for objects that collide with us or something like that, and then we can figure it out from there. That might work. Alright, we're going to want a int32 simulation ticks. We're going to have bool if we want it to be the debug version of this thing. We might as well have that max depth in there. And then like blur radius or something, but we can add some of this. We can add some of this stuff as we go along. map utils, call this to create a static flow field. So, what are we going to do? This is quite a bit of stuff to get started. We're going to need, I guess maybe I can get this all self-contained in the CVP file, so I don't have to do anything insane. Alright, so we're going to want water spawn source. And we're going to want like a public, like float x, y, I guess f vector, position. We're going to want like a float. Weight. Well, let's get a name on it as well for a water source, and I guess we'll sell like bool input. So we're gonna need one of those. We're gonna need a I guess we'd also want like a float, in radius, and f vector, m extents, and bool like is box. So get our extents, all this stuff, and box, put false, and weight. Just do 1.0, name. Well, I guess we have water spawn source. So water. Let's see. Water flow object. So we're going to want our class like calculated flow field, which is going to have stuff on it. So we'll do this more kind of object oriented. We'll do like a tick on this thing and all this sort of crap. So it'll be like void, like calculate paths, and like a tick, and then like a void, like fill color with paths, and then like void fill color with particles, all this sorts of crap. And we're doing this all in the CPP file. Compile time should be faster. We don't have to recompile the header every single time we want to do something. Yeah, I'll declare these ones and throw them somewhere lower, just to keep the class from exploding into a million pieces. Flow field data. Alright, as for variables, what are we going to have? We're going to have, I guess, a T-array of these water flow objects, which will be M inputs, T-array water flow object M outputs. We're going to want a calculated flow path. It's like class calculated flow path. Which would be, we'd have like the water flow object, and input, water flow object, and output. We'd have our path. What would the path be? I guess it's an array of nodes. Have a T-array of, I guess we have this flow path node, which is, we've got an X and a Y. We'll do the whole damn thing. Flow path map. Some of these could be structs. We'll need a cost for these sorts of things, because if we're going to do A star, we're going to need stuff. So we need a T-array of flow path nodes, which would be M path. Alright, so this one actually we're going to have a public function on. We're going to have it called calculate path. Alright, so this guy is going to have a T-array calculated flow paths, which will be M paths. And I guess we need to calculate a kind of a class of. We'll also want a flow path map for some reason. So we're going to have these flow path particles, and that's going to be, we're going to have an int32mx, int32my, we're going to want int32mlife, and we're going to want to have like an array of previous positions. Is there a pair? A T pair? Alright. And this would be like position history. And then we'll need like a function on this, which will be like void tick, and we'll pass in, you know, like a calculated flow field reference. Windows wants to update. Get out of here. Alright, this is going to be an F vector of F color reference out both of these. Alright, it'll have an F vector of F color, which is going to be path colors. And the reason we want like the paths here is because I'm going to have to draw this stuff on here. Yeah, so we're gonna like fill color with paths, fill color with particles, and fill color with flow. And that'll let us extract all the information we want. So I can like run the simulation for a set number of ticks and stuff like that, and then I'll be able to visualize it and stuff like that. And what we'd really want to be able to do is to like keep clicking a button over and over and like watch it tick one after the other. Like for falling ant moose. Also, an ant moose, I would not want to run into one of those in real life. That would be incredibly scary. Like, I imagine it's like a horrible cross between an ant and a moose, and you don't want to screw with a moose already. But if that moose had 6 legs and could like bench press 4 cars or something, then I think I would run away from that creature before fighting it. So if we want to be able to tick this thing, we're gonna have to put this calculated flow field, all the rest of this crap out in the header file so we can actually call it. Think the size of a moose with an ant's head. Yeah, right. Yeah, that's pretty much what I was expecting. That's horrifying. Also, hello EG696969. Welcome. I'm doing a whole bunch of coding stuff right now, so don't expect a whole bunch of pretty stuff, because we're not to that yet. We're still gathering all our information. So it's going to be a whole bunch of code here, and I'm still trying to figure out exactly how to do everything too. So it's not like I'm going to be like blowing through this. I'm just like, if I knew what to write already and how I wanted it all to work, I would be much faster. Yeah, that's what I figured. It's one of our strategies, right? Like, if you have somebody who's actually entertaining, like Adam, and then you show somebody not entertaining, like me, and like right next to each other, then like people are like, oh man, this is why I watch Adam, and they just like turn this off. But it's all good. So I'm trying to come up with all the data structures to calculate this flow field, so I can actually go write all this crap out. Thank you for following, EG. I'm familiar with your name since you're in Adam's stream all the time, so welcome. Except when things are getting salty. Oh, that's more interesting. This is going to school for programming, so seeing this much code, trying to figure out is nice. Not much of an animator. Well, Ant Moose, if you have any questions on anything, I always entertain questions and try to answer whatever I can. So while I am trying to do work here, I'm not like streaming to be super entertaining. I'm just actually doing work. So sometimes I'm just like, I'm just gonna do boring crap. I don't care. Like, we were fixing the build earlier. I mean, like, how entertaining is that? Oh man, header files with C++, and just like shaking my fist and then cursing the names of all the Unreal devs. So I'm going to need to call tick on this, and since I'm going to call tick, I'm going to need to throw this in the header file, and since I need to throw one thing in the header file, I need to throw everything in the header file because it needs to be accessible by blueprints, so I can actually grab like the calculated flow field data for this thing, and then I can kind of call tick on that, because if it's going to be static and everything else, then I'm going to want to... I'm imagining I'm going to need a button in Blueprint land that I can just keep clicking, and it's going to tick the simulation one step at a time, and then I can watch the simulation as it goes and kind of debug stuff. Otherwise, there's no way in hell I'm going to be able to debug this thing. So I'm going to have to put all this stuff out in the header file. Anyway, let's make sure our header file is available to all the things. Alright, so we got utils, and then we have map. Alright. So calculate paths and all this stuff. So we need to throw this crap in the header. So let's just go ahead and do that. Even though it's still kind of a work in progress, we should just set it up. Alright, so these are all U classes. Are we actually going to have generated U classes for these things? I think the only thing that's going to be a U class is the calculated flow field. Everything else could just be accessible. And these will be functions. So we're going to actually have this on our, alright, have this thing on our map, and we're going to have, we're going to need to call like void reset on this thing so we can clear out all the data. And this is going to be an actual U class, and the rest of it can just be stuff. Alright, so we need this to be a blueprintable thing. Blueprint read write. Needs to be a U object then. Alright, so that means we need a constructor for this bad boy. We also need to call this thing proper name. It's a U calculated flow field. Alright. So this guy is actually going to need to pass in a U calculated flow field reference flow field for the output, but it's going to be a reference. Alright. Got the flow field. The flow field doesn't have anything on it, so we can get rid of some of this. Alright. So let's just start creating some of our functions for all this stuff. And these are going to be needing to be U functions that we can actually call. So category map, yeah. Alright, so this will be called to reset all of our data. Call to calculate the A-star paths for the inflows / outflows, the water. Call to tick our water simulation. Call to snag our color paths. Our paths as colors. Call to grab our particles as colors. call to grab the actual flow field. Alright. Alright, this is going to have a reset method on it. We're just going to call reset from inside of the constructor. And this reset for our water flow object is just going to do what our initialization list did. We'll just chuck that thing in the trash can. And I haven't been streaming for a couple days because I went over to Seattle to send people off to Spain. We had like this surprise party for this guy, and like 20 people showed up for it, and it was actually a surprise. Like, this dude had no idea it was coming, and it was really funny. You know, like nobody actually spilled the beans, which was impressive for having like a party of 20 people organized like on Facebook, and have nobody actually just like, everybody actually read that it was a surprise party. It's not like the person went around and was like, don't tell this guy, and like, and these people were also in different states and like don't talk to each other. Like, his parents flew over from Ohio or something. And it was pretty funny because it was right after Beer Friday for Amazon. So like, this guy came in after having a few beers and being a little bit late, like 30 minutes late to this thing he was supposed to be to. So he like walks in and he's like, oh Jesus Christ, you know, I'm already three beers in, you know, like I better slow down, you know. But it was really cool. We got like, his parents were there, his wife was there, a whole bunch of friends were there. Like, I was there, and I don't live in Seattle, so like I drove over. He's just like, wait, you're not supposed to be here. You know, because he like looks there, and like first glance, you know, there's a whole bunch of people in the room. Like, okay, cool, you know, it's just like the people who live in Seattle. And then like he sees me, and he's like, you're not supposed to be in Seattle. And then like he looks in the back, and his parents are there from Ohio, and he's like, what is this? So it was pretty cool. So I pretty much drove over there, went to this party, and then I just drove back after that. So that's like 4 hours each way. So that was a lot of driving because I didn't sleep between those or anything. I just went there, attended party, and then went home. Alright, so we got that reset going on, and I should probably also call out where these different objects start. And I kind of like to do it like this. This will be our flow path particle. We're going to have a tick on him. And what also was kind of cool was one of the guys, he actually ran into somebody on the street, like, who was attending the party. And the guy actually handled it real well. He's like, oh yeah, you know, I'm just going to get pizza at this place, and yeah, you know, whatever, I need to go, bye. So we're also good enough liars, apparently. Alright, so that'll be taking a single particle. We'll have our calculated flow path, calculate path thing going on. And we need to set up a whole bunch of stuff in order to actually calculate all this. Write a whole bunch of code. Alright, so we have all those. And I think we'll just throw the constructor here, down here, because I don't like putting stuff in header files. because it's bad practice. And the reason it's bad practice is if you go change something, it has to compile everything that includes the header, which in large projects can be the universe. You don't want that. How goes the debugging? You're back from dinner. The debugging, well, we haven't even gotten to the debugging. We're into coding. We went over, like, we finished the header stuff. I don't know if you saw that, but I basically just didn't solve that problem with headers and decided to do something else because Unreal Header Tool sucks and it just doesn't work for that, so we couldn't use it. Calculated flow field is a U calculated flow field now. Alright, so this class holds the flow object. I'm starting on the actual data structures and everything to actually start doing the calculations. So we're gonna have to do like A star stuff on here. Alright, so we're going to stick this like you calculated flow field onto the actual water. Particle effects? Unreal doesn't have something built in for that? No, it is. They're not particle effects. You missed the whole diagramming and explanation for this thing, but basically what we're going to do is, in order to create the flow field for our water, I'm going to do A star between the inflow and all the outflows, so that'll make this line thing for our flow field, and then we're going to rubber band that, so we'll turn these jaggy lines into straight lines for stuff, because A star doesn't really work too well with that sort of thing. So we'll rubber band that a little bit, maybe. We'll see. I might not have to do rubber banding. I might be able to just blur the damn thing and call it good. What we're going to do is, in order to get this flow, we're going to be spawning particles for a set number of ticks. Like we'll tick the simulation, and every time we tick it, we spawn a particle on the left and right side of this line, of each one of these lines, and those particles will attempt to move towards the outflow from the line that they were spawned from. And if they collide, like, they'll try to just move kind of naively. And because like this, and we'll tick it from a certain direction, like we'll tick things so that the first frame, basically we spawn this particle and this particle, and this particle gets updated, tries to move south, but it can't, so it's going to try to move wherever it can, and it can't move to the left because that's occupied by the line, but it can move to the right, so it'll move to the right, and then next tick it'll be able to move down, and like all that sort of stuff. And the idea is the speed of the thing is going to be based on it. So these particles move slower as they move out and stuff like that, and they should fill up over time and kind of head down to where they should go. And that's what we're starting to code out right now, to give you kind of an idea. So it's not particle effects. Anyway, thank you for following there, Really Mask. We're going to be neck deep in programming crap today. So I'm just laying out the groundwork for all that. And that was after thinking about it for quite a while. Oh, I see. Sorry, you have to explain it. No, it's good. If I can explain it again, that means I might understand what the hell I'm talking about. And if, like, while explaining it, I think of something else that I've completely missed. Explaining stuff is something, that's why you go to meetings and like explain your code and your ideas to somebody. It's not just to explain your idea, it's to actually have your idea, you can articulate it, you understand it a lot better than just like, well, I think I understand how this works. And then you're like, no, I don't know how this works. I think there's a clip about that. Watch a tutorial. I know everything about how to do this. Sit down to write it. You're like, I have no goddamn clue what I'm talking about. It sounds like a good and simple idea. Well, there's a lot of little edge cases which I'm concerned about, which is we're going to have our particles. They're going to get stomped up here. And the idea is hopefully we can have the particles move faster, to kind of like they can actually skip a pixel or two on this big grid. Because they're close to the line and stuff like that, so that we don't, because the issue would be like if we have a whole bunch of particles here, and like if we just like filled stuff up, like kind of like just turn on a hose and like particles pour down, right? It's gonna fill up. Like we're gonna not, if we had a million bouncy balls, the bouncy balls are gonna get stuck because we have no concept of how deep this river is. We just have the width there, which is just garbage, right? So like all of our bouncy balls are going to try to pour into this thing, and they can't get out, and that's going to be, it's going to be unhappy. So what we're going to do is, instead of being unhappy about stuff, we're hopefully like we need like a flow that looks like that, and by these particles moving slower, we'll be able to have them, and by these particles moving faster, they're not going to build up. So when they get here, they're going to be able to go down real quick, and will drain. They'll drain out fast enough that the particles from above here will kind of be able to do stuff. And I don't know how that's going to work. How are we preventing those? By being really stupid with our grid system, right? So when you want to move somewhere, you just check in the grid if something's already in that location, and if it is, then you can't move there. So there's no n-square comparison for collisions. You just see if something's in a unit. Everything is the same width, right? Everything is a width of one box, and so there's no quote-unquote actual collision going on. It's just all dead simple. So that's the plan. Alright, we're going to need the reference stuff, I believe, for the output. Where is that? I forget the... So, input, reference, Unreal, C++. I can write a C++ blueprint with an input parameter that's a reference. Oh yeah, it's uparam ref. Alright, there we go. By default, passing something by reference in Unreal actually has it be an output, not an input. So for these guys here, for the input values, we want those to be inputs, not outputs. And I'll probably be refactoring some of this static flow field crap into kind of a larger data structure, kind of like I'm doing for the flow field stuff here, where I actually have like an object that contains all this data. That way I don't have to be passing around 20 goddamn parameters for everything. Because as my professor said, if you got more than 10 different values in your function, well, you probably forgot some. So yeah. Please, there are plugins that let you align parameters. I don't care. I don't like installing a whole bunch of plugins and crap like that. You just Because then you never know if like Visual Studio freaks out for some reason, if it's like your plugins or if it's Visual Studio itself or just whatever. I just don't like plugins for stuff because I like to know what's going on. And there's already enough issues with crap. So let's make it so we can actually put this structure onto our object in Blueprint Land. And we'll be messing with it. I know there are plugins, but I just don't like them. I don't like anything that screws around with the code. Like autocomplete to me is like the worst thing ever. Might even be built in. I know there probably already are built-in things to do it, and I probably disabled all of them. I just hate it when something changes the stuff that I typed. It's just so damned annoying. Missing variable name. What? How am I missing a variable name here? Fill color with paths. I don't see how this is missing anything. There's got to be something else that's busted with this. It's a U object. Something else is screwed up. Alright, we have our class, that's correct. We have our class, that's correct. You calculated flow field. This should be a class, so we can forward declare it. That's correct. I'm probably missing a semicolon or a brace somewhere. I don't know. I'm not applying it. I'm gonna type it out. I know you're trying to help, but I'm gonna dig my own grave here. It's just one of those things. I just hate it when I'm typing, and then like quote unquote fixes crap. It's just there's so many times where it's just like get out of my face, Visual Studio. All right. Well, let's just see if another error pops up here above it. No, it's still this. Why would this be all angry at us though? Like it's a void function. We got an f vector of f colors. Are f colors not valid things for f vectors? No, they're definitely valid. Missing variable name. Something's Is it the first instance where we're actually having an F vector of F colors? Well, then you'll just have to close your eyes, Synchron. Just imagine it's the plugin in slow motion. Alright, so there's something wrong with F vectors of F color references. Well, what if we just remove that reference? Is it the Unreal header tool that's freaking out here? Because this isn't a compile error. This is a Unreal header tool parse error. Well, let's just Google it. Missing variable name, U function. Let's see what this means. Have you tried this? So it says this happens when you're missing a variable name on your actual stuff, but I don't see anything. Like, there's a variable name right there. That is a variable name. It is. I swear. Right. Okay, so there's something wrong with the F vector, F color reference output stuff. What? Because replacing with N32 works. That's. Oh god, it's because I'm using F vector because I'm an idiot. That's T-array. I'm so used to like different terminology, so whenever I think vector, the first thing I think is not an actual mathematical vector. The first thing I think of is a frickin' array. I need to learn to read. Yeah, that's also just the Unreal header tool having, stupid bad error messages as well. It's not that the thing didn't have a variable name, it's that, they hard-coded stuff. Syntax error, T-array. It's not there wasn't a variable name there, it was that, a template type name, blah. And that'd be the Unreal header tool is, it can